In this lesson, we're going to look at two ways to describe data. We're going to look at a measure of center, which means like about how big is the average number in the set or the middle number in the set. And then we're going to look at the measure of spread, which means how different are our values? Are they way spread out all over the place, or are they all pretty much together in the same area? So whether the measurement that we use or the measure that we take is going to depend on what our data looks like. So we have data that can be symmetric or skewed, right? So let me show you an example of each. Symmetric would be like a bar graph that looks like this. Bar graph, a histogram, right? We're talking numerical here. This is all for numerical data. So if we have a histogram that looks like this, you can see that the general shape is the same on the left as it is on the right. It doesn't have to be exactly the same to be symmetric. It just has to be pretty close. We could see that with a dot plot in the same way, right? Or a line plot, sorry. If it is about the same on this side as it is on this side, right? Then that would also be pretty symmetric, right? Now, sometimes we have data where all the points are on one side or the other, or the bars are really tall on one side and really short on the other, and that's called skewed data. So if our data is symmetric, we're going to use the mean to find the measure of center, which is the average, right? Add them all up, divide by how many numbers you have. And we're going to use the range as the measure of spread, which is just the biggest number minus the smallest. If we have skewed data, we're going to use the median, which is finding the middle. We're going to go over that. And we're going to use the IQR as the measure of spread. We're going to go over that too. Same thing if we have outliers. In this lesson, I'm going to show you how to find if there are any outliers, identify them, and if we have outliers present in our data, then the best measure of center is median, the best measure of spread is the IQR. All right, so let's get started. The table shows the length in inches of fish in a pond. Determine if the data contains any outliers. If so, list the outliers. So the first thing that we need to do when we're trying to figure out if there are outliers is we have to put our numbers in order. So I'm going to do that, and then I'll be right back. Step is to find the median. We did this in the last lesson, but in case you forgot, we're going to cross out first and last, first and last, first and last until we find the middle number. So if I do that, first, last, first, last, first, last, I find that the middle is right between 13 and 15, right? It would be right here. Now, there's no number there, so I have to take an average of the two numbers in the middle. 13 plus 15 divided by 2 is 28 divided by 2, which is 14. So 14, let me write it right here. 14 is my median. Sometimes this can be referred to as Q2, quartile 2, right? That's my median. But now what that does is it separates my data into a lower half and an upper half. So now I'm going to look at these numbers in the lower half, and I'm going to do it again. I'm going to find the middle. I have 4 numbers, so the middle would be right here. This is Q1. And the middle, right between 9 and 11, I would find the average, or sometimes it's an easy situation where you can just say, oh, well, 10 is right in the middle. That is the Q1 value, so I'm going to write 10. If you can't tell like what number is exactly in between, then you just take an average, right? 9 plus 11 is 20, divided by 2 is 10. All right, on the other side, I again have 4 values, right? These 4 values, so I'm going to find the middle. And the middle is right here. And I know that the number that's exactly in the middle between 15 and 19 is 17. That number is equidistant from 15. It's 2 away from 15, it's 2 away from 19, right smack in the middle. So this is my Q3. Okay, so that's step number one, is to find your Q1, Q2, and Q3 ranges. Really, you only need Q1 and Q3, but you have to find Q2 first. Okay, now we're going to find the IQR. The IQR tells us how much distance there is between Q1 and Q3, right? If we were to draw a box plot like in the last lesson, it would be the length of our box. Not the lines that go out the side, but just the box. So to find the IQR, we're going to do Q3 minus Q1. And that is 17 minus 10, which is 7. So our IQR is 7. Now we're going to find if there are any outliers. And there's a formula that we're going to use to determine that. So here's your formula for the lesson. There's only one formula that you need to know for this lesson. And we're going to do Q1 minus 1.5 times the IQR. And then we're going to do Q3 plus 1.5 times the IQR. Now, we know order of operations, and order of operations tells us we need to multiply before we subtract. So my Q1 is 10 minus 1.5 times my IQR, which is 7. All right, so that's going to give me, so 1.5 times 7 is 10.5. So now I've got 10 minus 10.5, so that is negative 0.5, right? So now I'm going to do the same thing with this other formula. So what I'm doing basically is I'm finding 1.5 times the IQR, and then I'm going that much less than Q1 and that much greater than Q3, right? So now I'm going to do Q3, which is 17, plus 1.5 times the IQR, and that is 17 plus 10.5, and that is 27.5. Okay, so now to determine if I have any outliers, I need to see if I have any values that are less than this or greater than this. Anything outside that range, because remember, I'm going 7 this way. Wait, sorry, 10.5, right? Yes, I'm going 10.5 this way, and I'm going 10.5 this way, and I'm seeing if there's anything outside of that range. And where did 10.5 come from again? 10.5 came from this right here, right? 1.5 times my IQR. All right, so I do have a number outside that range. On the left, I don't have anything smaller than negative 0.5, but I do have something larger than 27.5, and that's 28. So there is an outlier in this data. Now, in the rest of the problems that follow, I'm going to skip all of this because this is a long process, and if I do this on every problem, like explaining it for every problem, it's going to be a very long video. So if you forget how to find the IQR, if you forget how to find, if you forget these formulas down here, it is always 1.5. It's not 1.5 just for this specific problem. It's always Q1 minus 1.5 times the IQR and Q3 plus 1.5 times the IQR. A really common mistake is to do the addition and subtraction first, so make sure that you're following the order of operations. If you put it in on your calculator will do the order of operations for you. So if you put in 10 minus 1.5 times 7, it will multiply before it subtracts. It's the beauty of scientific calculators. All right, so let's try another one. All right, actually, let me erase what I wrote here. So this is our data, and we could list all of this data out and do the same thing we did in the last problem to see if there are any outliers, because that would tell us whether we should use median or mean. But there's another way. Remember, in the beginning, we can also just look at the shape of the data. This data, is it symmetric? Does it look the same on the left half as it does on the right half? It does not. This data definitely looks different on the left half and the right half, right? The left half looks like this, and the right half looks like this. This is not symmetric. This data is skewed. So because it's skewed, we would use the median. This is another example of skewed data. All of our points are over here, right? And then we've got a few over here. So this is very skewed data. So again, we would use the median. And this is our last example, this time a histogram of skewed data. You can see the bars on the right are much taller than the bars on the left. It's definitely skewed. So we would again use the median. So to know if this is skewed or not, we're going to need to know if there are any outliers. So we're going to have to go through the process that we used in the first problem, but it's going to be a little shorter because since we have a box plot, we already know Q1 and Q3. All we have to do is follow this line down, and we see that 15 is our Q1. Follow this line down, and we see that 21 is our Q3. So to get our IQR, we subtract them. So 21 minus 15 is 6. So that is our IQR. Now we're going to use our two formulas. Excuse me. So we're going to do IQR. So we're going to do Q1 minus 1.5 times the IQR. And that is going to be 15 minus 1.5 times 6. And that's 15 minus 9. And that is also 6. So do we have any numbers that are smaller than 6? We do not, right? That's all the way over here. So we're good on that side. Let's check Q3. So now we're going to go larger than Q3. So now we're going to do Q3 plus 1.5 times the IQR. And that's going to be 21 plus 1.5 times 6, which is 21 plus 9, which is 30. Do we have any values larger than 30? Yes, our largest value is right here, 31. So we do have an outlier here. Since we have an outlier, we want to use the interquartile range as the measure of variability. All right, and that would be our IQR is 6. Save us a little bit of time. I wrote the numbers for player A in order. I found the middle, Q2, and then I found the middle of the lower half and the middle of the upper half. So now my IQR is Q3 minus Q1, which is 3.5 minus 1, which is 2.5. So now I'm going to do my two formulas to see if I have any outliers. So I'm going to do Q1 minus 1.5 times my IQR, and that's 1 minus 1.5 times 2.5, and that is 1.5 times 2.5 is 3.75. So 1 minus 3.75, which is negative 2.75, right? To find that upper bound or limit, so I'm going to do Q3 plus 1.5 times the IQR. And that's going to be Q3 is 3.5 plus this number that I got, 3.75. And that equals 3.5 plus 3.75 is 7.25. So I'm going to write these numbers up here. My IQR was 2.5 for this player. The lower bound, the least number I could have is negative 2.75, and the largest number I can have is 7.25. All right, I'm going to do this for the other player too. Found the IQR for the other player, and I did our formulas, Q1 minus 1.5 times the IQR and Q3 plus 1.5 times the IQR. And what I found here is, hold on, correction to make. So I want to look for any numbers that are outside of these limits, right? My lower limit and my upper limit. And for player A, we do have a number that's larger than 7.25. It's right here. And then for player B, we have a number that's larger than 5.25, right? So both data sets contain outliers. And what that means is that for the measure of variability, we want to use the IQR. So when we look at the IQR, the way that we use it is the smaller the number, the more consistent the player, because it means that their results were all kind of in the same place, right? They're closer together. They got pretty much the same thing every time. So that would mean more consistency. So the player that was more consistent was player B. All right, one more. Next one is a stem and leaf plot. And if you don't remember how to read a stem and leaf plot, go check out the video from the last lesson. But I already wrote the values in order, found Q2, found Q1, found Q3. So now I would find my IQR, which is Q3 minus Q1. So that's going to be 32 minus 21, which is 11. So now I'm going to do my two formulas. So I'm going to do Q1 minus 1.5 times the IQR. And that's going to be 21 minus 1.5 times 11. And that is 0.5. And then I'm going to do Q3 plus 1.5 times the IQR. And that is 32 plus 1.5 times 11. And that is 48.5. So now I'm just going to double check that. So 1.5 times 11 and then plus 32. Yes, 48.5. So now I need to look at my data set. Oh, you know what? My data set's missing the last number. 49's not up there. Okay, so now I need to see if I have anything smaller than 4.5 or greater than 48.5, and I do. Here it is. That's why I was double checking. 49. So because I have an outlier, the more appropriate measure for variability in this problem is going to be the IQR. And that's it. So as usual, if you have any questions, let me know, and I'll talk to you guys soon.